Good day, everyone. I am Kristen Joy Lanciana Bentanilla, BSIS 1A.
Hi everyone, I am Jancy Blanca.
Hello everyone, I'm Charicel Magno.
Hi everyone, I am Roxanne Jasonia de Banse.
Hello everyone, my name is Mary Ann B. Rilos.
Hello everyone, good day. I'm Chris Lawrence Palmerola.
I am Leonard Kente Molina.
Armando O. Valenzuela Jr.
I'm Marian J. Portasio.
Hello everyone, I am Mary Abel Dad.
Hi, this is Skinny Orala Zoilo of BSIS 1A.
Hi everyone, good day. I'm Josan Riley, BSIS 1A.
Hi everyone, my name is Silana Blasado from BSIS 1A. Thank you.
And I am Rika B. Bazar, and we are the BSIS 1A Tribe 3 Arithmetic. For this video, we are going to discuss the measure of central tendency, measure of dispersion, and the measure of relative position of Chapter 4 in Statistics. So, let's proceed to our topic. Statistics is the mathematics we use to collect, organize, and interpret numerical data. Statistic is used to describe and analyze sets of test scores, election results, and shoppers' preferences for particular products. So let's proceed to the measure of central tendency of ungroup data. What are the measure of central tendency? Also referred to as the measure of center or central location. It is a summary measure that attempts to describe a whole set of data with a single value that represents the middle or center of its distribution. There are three main measures of central tendency: the mode, the median, and the mean. Each of these measures describe a different indication of the typical central value in the distribution.
My topic is about mean. Mean. The mean, commonly called the average of a set of n numbers, is the sum of all numbers divided by n. The mean is most popular among the measures of central tendency, for it is widely used. It indicates a point around which the values in the distribution balance. This can easily be justified by showing that the sum of the differences from the mean is equal to 0. It is also affected by extreme values. To get the mean, you need to follow this. Add the numbers, then divide by the amount of numbers. This is the example of mean. 9, 3, 1, 8, 3, 6. 9 plus 3 plus 1 plus 8 plus 3 plus 6 equals 30. And 30 divides 6. 6 is the given number. 30 divided 6 is 5. Now, the mean is 5. Mean have two content, mean ungrouped data and group data. Ungrouped data is the data you first gather from an experiment or study. The data is raw, that is, it is not sorted into categories, classified, otherwise grouped. An ungrouped set of the data, basically a list of numbers. Mean ungrouped data, where mean, scores, sum of the scores, total frequency. Example of ungrouped data. The following are marker score in statistic quizzes during the first quarter: 70, 72, 77, 78, 86, 84, and 79. To get the ungrouped data, you need to follow this. A. Compute for the mean of the average of the scores. B. Show that the sum of the differences of the scores from the mean is 0. C. Show that it is greatly affected by extreme values. Solutions. Mean, sum of the scores over total frequency. Sum of the score 70 plus 72 plus 77 plus 86 plus 78 plus 84 plus 79 over total frequency is 7. You need to add sum of the scores and then divide it by 7. The ungrouped data now is 78.
Hi everyone! I am going to discuss the midjan. The midjan is the midpoint of the data array. Before finding this value, the data must be arranged in order, from least to greatest or vice versa. The median will either be a specific value or will fall between two values. For example, you have a given data, and the given data is odd numbers, so you have a middle value. For example, we have a given here. The median is x sub 3. That's the median. But if the given data is even, you have a 2 middle value. You need to add the 2 and divide it by 2. Okay, another example. 8 novels were randomly selected and the numbers of pages were recorded as follows. 415, 398, 402, 400, 420, 415, 407, and 425. To find their median, we need to arrange the data in order. So, dyan, nakikita nyo naman, I arrange the data in ascending. So, the data given is even. So, we have a 2. But take note, the median is only 1. We need to add the 407 plus 415 divided by 2 is equals to 411. That's the median.
The last of central tendency is the mode. What are the mode? It is the value that occurs most often in the dataset, the number or value of observation in a dataset which appears the most numbers of time. For example, find the mode of the given dataset 15, 28, 25, 48, 22, 43, 39, 44, 43, 49, 34, 22, 33, 27, 25, 22, and 30. So, to find the mode, arrange the dataset in ascending or descending order. So, I arrange this dataset in ascending order. 15, 22, 22, 22, 25, 25, 27, 28, 30, 33, 34, 39, 43, 43, 44, 48, 49. So, in the given data, the number that appeared the most number of time is 22. So, 22 is our mode, and the dataset is said to be unimodal because it's only one. Another example, the speed of 10 stenographer in typing per minute are as follows: 121, 110, 120, 119, 112, 121, 118, 115, 107, and 115. To get the mode, let's arrange this in ascending or descending order. So I arrange this in ascending order. So it's 107, 110, 112, 115, 115, 118, 119, 120, 121, 121. In this dataset, there are two modes, the 115 and 121. So our modes is the 115 and 121. This data set is said to be bimodal because there are just two modes. Another example, find the mode of the given data. Number 2, 5, 8, 9, 11, 4, 7, and 23. So because there is no data set appears, there is no mode.
Ang pag-uusapan natin ngayon is about sa weighted mean. So, ano ba ang weighted mean? Mean is a point in a data set, which is the average of all the data points we have in a set. It is simply calculated by taking a sum of all data points and divide by a number of data points. So, basically, all the data points are given equal weights when we calculated the simple mean. So, magbibigay tayo ng example dyan. So, ito yung formula at kung paano gagawin. So, ito yung dataset natin. 4, 6, 8, 22, 9, 83, 98, 45, 87, 10. So, yan yung dataset natin. Sa weight natin, 20%, 15%, 10%, 10%, 5%, 3%, 2%, 7%, 5%, and 13%. So, paano natin makukuha yung weighted mean nito? So, ganito yung gagawin natin. Open and close parenthesis. 4 times 25%, close parenthesis, plus 6 times 20%, 8 times 10%, 9 times 10%, 22 times 5%, 83 times 3%, 98 times 2%, 45 times 7%, 87 times 5%, 10 times 13%. So, ang sagot niyan ay 18.25. So, paano natin sabing yung weighted mean natin is 18.25. So, inattach na natin siya dito. Yung weighted mean formula, tapos yung sum na ito, tapos yung weighted mean is 18.25. So, yun yung example na ginawa ko.
Another, frequency distribution. A frequency distribution, which is a table that lists observed events and the frequency occurrence of each organized raw data. So, where to use the frequency distribution table? A frequency distribution table can help you organize this data to find out if frequency distribution is a chart that summarizes values and their frequency. It's a useful way to organize data if you have a list of numbers that represent the frequency of a certain outcome in a sample. For example, you survey the numbers of computers per household. In the first box, these are the responses. So, we are going to find the dataset and we need to use frequency distribution to present the dataset into table. Here in the first column is the number of computers, and here in the second column is the number of households that have a computer. So this means that there is 5 households that no computer, 12 households that has 1 computer, 14 households that have 2 computers, and 3 households have 3 computers, and so on. The number is total of 40. So to get the answer, let's use the weighted mean. So 0 times 5 plus 1 times 12 plus 2 times 14 plus 3 times 3 plus 4 times 2 plus 5 times 3 plus 6 times 0 plus 7 times 1 over 40, the equal of the population that responses, is equals to 79 over 40. So the answer is 1.975. So our mean number of computer per household is number.
So, hi everyone, I am Jency Blanca and I am going to explain about the measure of dispersion. The measure of dispersion describes the spread of the data. They include the range, interquartile range, standard deviation, and variance. The range is given the smallest and largest observations. This is the simplest measure of variability. So the range is the simplest measure of dispersion. The range can be thought of in two ways as equality. The difference between the highest and the lowest scores in a distribution. Range is the statistical measure of dispersion, highlighting how different the numbers are. So these are the important things to do or to be able to find the range of the numbers. So first we have to gather your data so you know all the numbers to be studied. Second, arrange the data set in order from least to greatest. Then third, write a subtraction sentence to subtract the smallest value from the greatest value. So example, if you read a book Monday to Friday and wrote down how many pages you read each day, you can take the range. So we have to evaluate the days and its pages. So we have here Thursday, which is 3, Friday 8, Tuesday 9 pages, Wednesday 11 pages, and in Monday you read 12 pages. So we have to find the lowest and the greatest value. The greatest value here is of course Monday 12, and the lowest value is Thursday, which is 3. And then what we're gonna do is you have to subtract the lowest value from the greatest value to get the range. So we have here R is equals to highest value, which is 12, minus or subtract to the lowest value, which is 3, is equals to 9. So we have here the 9. The 9 is the range of this data set. Then we have here another sample. Metro Manila estimated population is 100,123. In Central Visayas, we have 99,235. In Mindanao has 85,000, and in Western Visayas has 70,833 estimated population. So we have to evaluate it again. Places and its population. So we have here Western Visayas is 70,833. Mindanao is 85,000, and Central Visayas is 99,235. In Metro Manila, we have 100,123. So, which is the highest and the lowest? So we have here Metro Manila is of course the highest, 100,123. And the lowest is the Western Visayas, which is 70,823. So we have here R is equals to the highest, 100,123 minus to the lowest, the Western Visayas, 70,833. So the range of population is 29,290.
Hi everyone, good day. Before I start, I would like to introduce myself to you. I am Chris Lawrence Parmeron. The topic that I have to discuss now is variance. I explain to you what is the meaning of variance. The term variance refers to a statistical measurement of the spread between numbers in a dataset. So, this is the formula of variance deviation. For a population, the variance is calculated by variance is equals to the summation of the quantity of x minus the mean all over to n. So, another equivalent formula is variance is equals to the summation of the x squared all over to n minus to the quantity. So that if we need to calculate the variance by hand, this alternate formula is easier to work with. So that's all for thank you.
So before I start my discussion, I would like to introduce myself. I am Armando Valenzuela Jr. What is standard deviation? Standard deviation is the positive square root of the mean square deviation of the observations from their arithmetic mean. The standard deviation formula. So, we're going to calculate the standard deviation of a set numbers. Now, this is two formulas in B, where the first one is the population standard deviation. Now, this formula is represented by the letter sigma. Thus, the standard deviation is equal to the sum of all the differences between every point in the data set and the population mean as mu, and then you need to square divided by n, which is all of the numbers in the set, and you're gonna take the square root of the always whole. So that's the population standard deviation. The next form is the sample standard deviation. So let's say if you have just a sample of a population, not the entire population, if you have a sample data or the entire data, then you wanna use this form. S, which is the standard deviation, is equal to sigma, the sum of all the differences between every point and the mean, that's the sample mean, and the other equation we have the population mean represented by mu, but this is the sample mean. So that's all. Hope you learned something from my discussion. Thank you.
Hello everyone, I'm Charicel Magno. Today we're going to discuss about the procedure in computing standard deviation. Determine the mean of n number. For each number, calculate the division difference between of the number. Calculate the square of division and find the sum of this squared division. If the data is a solution, then divide the sum by n. If the data is simple, divide the sum by n minus 1. Find the square root of the quotient in step 4. Example, the following number were obtained by simplifying population 2, 5, 7, 10. So, first step, find the mean of the given data set. Mean, sum of given data set, over number of the given data set. 2 plus 5 plus 7 plus 10 equal 24 over 4. Why over 4? Because 4 is given data. For you to find, count the number given data set 2, 5, 7, 10. So 24 divide 4 equal 6. So the mean is 6. Step 2. Compute the variance. The formula using a sample. For using formula variance of the sample, let's identify the formula. Our x is given to 2, 5, 7, 10. Our mean is 6. Our n is 4. Now, we'll have identified. Let's now substitute. So, s squared equal 2 minus 6 squared plus 5 minus 6 squared plus 7 minus 6 squared plus 10 minus 6 squared over 4 minus 1. Why 4 minus 1? Because the n is 4 minus 1. Well, added it all is 34 over 3. So 34 divided by 3 is equal 11.33. Then compute the standard deviation. This is the formula. S squared equal square root of the variance. Square root of the 11.33 is equal 3.36.
Hello everyone, I am Margie Ibildad, and today I'm gonna show you how to find the standard deviation in this problem. So let's take a look to this example. Following data are the scores of grade 10 student during the competition in mathematics. The student 1 is 92, student 2 is 83, student 3 is 88, student 4 is 96, and student 5 is 95. So first, we have to look for the range. Range is the highest value minus the lowest value. So our highest value is 96 minus the lowest value, which is 83. So our range is 13. Now, let's find the mean. The mean is the sum of the given data set divided by number of the given data set. It equals to 92 plus 83 plus 88 plus 96 plus 95 over 5. So, it is equals to 454 divided by 5. So, our mean is 90.8. Now, let's calculate for the variance. So, this is the formula. 92 minus 90.8 squared plus 83 minus 90.8 squared plus 88 minus 90.8 squared plus 88 minus 90.8 squared plus 96 minus 90.8 squared and 95 minus 90.8 squared. So, we divide it by n minus 1, so our n is 5 minus 1. So, when we added it all, it is 114, and 5 minus 1 is equals to 4. So, when we divide the two, 114 divided by 4 is equals to 28.7. So, our variance is 28.7. Now, we have to calculate for the standard deviation. Standard deviation, all we have to do is to find the square root of the variance. The square root of the 28.7 is equals to 5.36. So, our standard deviation is 5.36.
Hi everyone, today you'll tackle about measure of relative position. Measure of relative position have three contents, which is percentile, quartile, and z-scores. Percentile. A percentile is a measure of use in statistics indicating the value below which a given percentage of observations in a group of observations fall. The formula for percentile is: percentiles can be calculated using the formula n is equal to p divide 100 times n, where p is equal to percentile, n is equal to number of values in a dataset, sorted from the smallest to largest, and n equal original rank of a given value. Percentile are frequently used to understand test scores and biometric measurements. The 25th percentile is also called the first quartile. The 50th percentile is generally the median. If you're using the third definition, the 75th percentile is also called the third quartile. The difference between the third and first quartile is the interquartile range. For example, the score for students are 40, 45, 49, 53, 61, 65, 71, 79, 85, and 91. So, what is the percentile for score 71? Here's the solution. Number score below 71 is equal to 6. Total number of scores is equal to 10. The formula for percentile is given us. Percentile of 71 equals 6 divide 10 times 100 equal 0.6 times 100 is equal to 60.
Hi everyone, I'm Marian J. Portasio. I'm going to discuss about quartiles. Quartiles are the values that divide a list of numbers into quarters. Put the list of numbers in order. Then cut the list into 4 equal parts. The quartiles are at the cuts. Quartiles, the first quartile, Q1 is the value that constitutes the 25th percentile. The second quartile, Q2 is the value that constitutes the 5th percentile. Note that the second quartile, the 5th percentile, is the median. The third quartile, Q3 is the value that constitutes the 75th percentile. Example, the sample data is 5 to 8. Put them in order and cut the list into quarters. And the result is Q1 is equals to 4. Q2, which is also the median, is equals to 5. Q3 is equals to 7. Another example, find the first quartile. So the sample data is 11 to 25. N equals 11. So Q1 is 25th percentile. So the first step is to find the index number for N11 and P equals 25. So the P is 25% and N equals 11. So 25% divide 11 is equals 2.75. So round up and use the value in the third position. Q1 is equals to 13 because the 13, that is the third number on the list. Interquartile range. The interquartile range, IQR, describes the middle 50% of a range. Find the IQR by subtracting the first quartile from the third quartile. So, IQR equals Q3 minus Q1. Another example. The sample data is 2 to 8. So, the interquartiles range is Q3 minus Q1 equals 7 minus 4 equals to 3.
Hi, this is Kini Oralozoila of BSIS 1A. So, I am presenting the finding the quartiles of a dataset. What is a quartile? A quartile is a statistical term that describes a division of observations into 4 defined intervals based on the values of the data and how they compare to the entire set of observations. So, nakikita po natin is quartile formula. Lower quartile or Q1 is equals to M plus times 1/4. Middle quartile or quartile 2, M plus 1 times 2/4. And the upper quartile or quartile 3, M plus 1 times 3/4. So, example, Dax and Whisper plot an interquartile range for, in this case, all the quartiles are between numbers quartile 1 is equals to 4 plus 4 divided 2 is equals to 4. Quartile 2 is equals to 10 plus 11 divide 2 is equals to 10.5. And the quartile 3 is equals to 14 plus 16 divide 2 is equals to 15. Using the formula, the upper quartile formula is 3/4 m plus 1 term. The formula doesn't give you the value for the upper quartile. It gives you to the place. For example, the 5th place or the 76th place. Step 1 is put your numbers in order 1, 2, 5, 6, 7, 9, 12, 15, 18, 19, and 27. Note, for very large data sets, you may want to use Excel to place your numbers in order. Step 2, work the formula. There are 11 numbers in the set. So, quartile 3 is equals to 3/4 m plus 1 term. Quartile 3 is equals to 3/4 11 plus 1 term. Quartile 3, 3/4 12 term. Quartile 3 is equals to 9 term. In the set of numbers 1, 2, 5, 6, 7, 9, 12, 15, 18, 19, 27, the upper quartile 18 is the 9th term or the 9th place from the left.
Hello everyone, this is Josan Enrile from BSIS 1A. In this video, I'm gonna show you what a C-score is. Standard score or the C-score is used when direct comparisons of row score is impossible. It determines the proportions of the total area greater than, in between, or less than an empirical value. It transforms the original scores into units of standard deviation. If the C-score is positive, score is above the mean. If the score is 0, the score is the same as the mean. If the C-score is negative, the score is below the mean. We're gonna use this formula for converting the score to C-score, the row score to C-score. We have the formula here. Z is equals to X or the row score minus mu or the mean all over the sigma letter or the standard deviation. Where X is empirical value or row score, mu or mean of the population, sigma or the standard deviation. We have first example here. The given is the mu is 8, the standard deviation is 1.2, the row score is 81. So find the Z. Okay, apply the formula. Substitute the given number. So x equals to x minus mu all over 0. Substitute the row score is 81 minus the mean is 8 all over standard deviation, the 1.2. Using our calculator, 81 minus 8 divide 1.2 is 60.83. So, if the C-score is positive, the score is above the mean. Example 2. A national achievement test is administered annually to third graders. The test, 100 items, has a mean score of 80 and the standard deviations of 15. If Jane's scores is 1.20, what was her score in the test? Okay. Using our formula, Z is equals to x minus mu all over standard deviation. Substitute the given. The x or the raw score is 1.20 minus mu or the mean is 80 over 15, the standard deviation, is equals to negative 78.8 divided by 15 is 5.26. So the scores of Jane in the test is negative 5.26. The score is below the mean. That's all. Thank you.